Okay. So number one, first rule, if f is continuous on the interval a to infinity, then the integral from a to infinity of f of x dx would be written this way. So this is the rule, right? So you replace the infinity with the limit, because infinity is not a value, so you have to be proper. So we'll replace infinity with b approaching infinity. So as b approaches infinity, it's supposed to be infinity there. Of the integral from a to b. Okay, so you just change the integral. So if you have infinity in there, this is improper, so you change it to that. And then once you take the integral, you apply the limit, like back in Cal 1. Number two. If f is continuous on the interval negative infinity to b, then the way you're supposed to write it is like this. So if you have a negative infinity down here going to b of f of x dx, just change it to the limit as a approaches infinity of the integral, I'm sorry, negative infinity. Number three, if f is continuous on the interval negative infinity to infinity, let's say it's infinity on both ends, right? Then you have to have separated into two integrals. Then you write like this. Negative infinity to c of f of x dx plus the integral from c to infinity of f of x dx. And then you apply rules 1 and 2 to this, right? You see what I mean? So go ahead and write it anyway. So the limit as b goes to, or sorry, a goes to negative infinity of the integral a to c f of x dx plus the limit as b goes to infinity from c to b of f of x dx. Do you see the idea? We're just trying to, it's just notation really, 8.8. There's nothing really new here. It's just a notation that tells you how to properly write these. So if you remember your limits from Cal 1, and you know, and all the integral techniques we've done already, right? We've done nothing but integrals. Then it shouldn't be a big deal. All right, let's do some examples. So first thing you need to do is rewrite it, right? We said use the limit as b approaches infinity, and then you change this from 1 to b. 1 over x to the 5th dx. And this integral will be x to the -5, right? So that in the antiderivative will be negative. Well, actually, we've got to write the limit first. The limit as b approaches infinity of negative x to the -4 over 4 from 1 to b. So then write the limit one more time. So that'll be as b approaches infinity, negative b to the -4 over 4 minus, which will be a minus minus, right? So it'll become plus in a moment. 1 to the -4 over 4. So you see this is going to be in the bottom, right? This is a negative power. So in the limit, since this is on the bottom and b goes to infinity, this is going to go to 0. So this zeroes out when you take the limit, which leaves you with a 1/4. So in the questions in the homework, they're going to ask you, okay, does it converge or diverge? So if you find a finite number converges to 1/4. If you get infinity, the limit, then you would say the integral diverged. Are there any questions on any of these steps?
Why the number, the -4?
So it was 5 to begin with, and I brought it to the top, right?
Yes.
If you integrate this, you add 1, which makes it -4. Then
Oh,
you,
okay,
and
yeah,
then you
yeah,
divide by that, so that made it negative, right?
okay.
Any other questions?
Give me 1 second. Write down this.
So basically, all you're doing here is taking in, you're integrating, and then once you're done integrating, you take a limit. That's basically it. So it's not anything new.
Okay,
Okay. Alrighty, so what are we doing? Oh yeah, next example. So same stuff, which is have different types of limits. So this time we're gonna have 1 to, still 1 to infinity, but the function will be 1 over oh, I see. 1 over 5th root of x, so 5, which will be rewritten as x to the negative 1/5 dx. Forgot the dx here. Okay, so now we write it properly. We need to introduce limits because infinity is not a number. So that'll be, as b approaches infinity, the integral from 1 to b of x to the negative 1/5 dx. Take your integral. We've got to keep writing the limit until it's done, until you take the limit, of course. So add 1 to a 5th. That'll give us what, 4/5? Divide by 4/5, that's going to be 5/4. So here is the antiderivative, right? Okay, so now plug it into the fundamental theorem of calculus, right? So that'll be 5/4 times b to the 4/5 minus 5/4 times 1 to the 4/5. So what is this going to do here when you take the limit?
0.
Is it? What's the power?
Oh, flips the reciprocal.
It's only 0 if it's on the bottom, but it's not negative anymore. Yeah, this is going to be infinite. So the limit turns out to be infinity. So this integral diverges. And this is how you show that it diverges, because there is no finite area or value. Then, is there any questions on this example?
That statement that you did at the end, this integral diverges,
Mhm.
do you have to state it, or is this just for us to know?
The question is going to ask you, does it does this diverge or converge? And you got to choose one or the other. And this is how you show how why or why it doesn't.
Oh, I see.
Like in an exam, I'm probably only going to ask you, does this integral converge or something?
I see.
I think the homework too, it looks easy because it's just 50% chance, right? But you want to force yourself to show this work because it's going to be important. Okay. Any other questions on number 2?
No, sure. Give me a chance to write it down.
Okay. So far is not too bad, right?
No. Okay.
So for the next one, let's do one that has a negative infinity, but also the integral is a little harder. Because, you know, we've done all kinds of integral types. So this is the integral of negative infinity all the way into 0 of x e negative x dx. So this is rule number 2. So let the limit as a goes to negative infinity of the integral a to 0 of x e negative x dx. So what type of technique would you guys use here?
Mm,
How do you integrate this?
Partial integration.
Yeah, the by parts, right? So we will let u be the easy one to take a derivative of, and dv be e to the negative x. So du is equal to dx, which implies that v would be the integral of this, which is negative e negative x. Okay, so the formula for by parts, right, just to remind you, is u, integral of u times dv is equal to u times v minus the integral of v du, right? You guys remember? We did the, and then I showed you the tabular method. Okay. So the integral will be u times v, so x times e to the negative x, minus the integral of v du. So v du, so negative e negative x dx, right? So the limit as a approaches negative infinity, vx e negative x, plus is a double negative, but when I integrate that guy, it's going to be negative again. So that's a triple negative b itself. Okay. Any questions on the integration step?
I know I'm gonna get it. Right now I'm a little lost. I'm just writing.
You don't remember the by parts?
I remember.
I
I don't,
really don't
I
remember
don't. When do we see that? Like calculus 1 or pre-calculus?
No, beginning of chapter 8, 8.2, I think, 8.3 maybe.
Oh, man, I don't remember. I don't know.
Remember we talked about how the tabular method, and you're like, oh, okay, and you said you liked that one. But this was the original method. Let me refresh your memory.
Yeah, I'm not.
So let me read you
Okay.
the notebook. Okay. It was 8.2. So it was the very beginning. 8.2. Find it.
That was not Wally's formula, right?
I think it was before we did that.
I don't have 8.2. I have 8.1 and then 8.3. Did I skip that class? Or- I don't know.
Maybe. Huh.
I
That's weird.
think it was, you did that on, you put that on YouTube or whatever. But I think we didn't have a class on that day.
Yeah, I think that we watched. No, that was something else. Pretty sure.
So I remember that.
Let's see. Hold on. Let me see if I can find it. I remember you guys asking about the tabular method. That's the only reason I'm convinced we talked about it. Let me check. Let me check my YouTube videos.
I'm checking it right now.
Oh, weird. Yeah, I have, yeah, 8.2 is on there on YouTube.
I
We-
put the 0.2 into 8.3, yeah.
Yeah, so it's on there. I just don't have the file that I sent out. I don't see the file. That's weird. But I do have the video. So we did talk about it. But maybe you missed that day, Felipe. I don't know.
Most probably.
Oh, but we'll do it now then, right? So this is the
Yeah.
formula for biparts. Right here. So the idea is you pick a U and a DV. You want to pick a DV that is easy to integrate because otherwise this defeats the purpose. So I chose, so here's my, this is my U, this is my DV. See what I mean? So if I let DV be this, to find V, I need to integrate that piece. So I integrate this guy to get that one. So there's V.
Okay.
If I choose this to be U, take a derivative, so that's just dx. So then you plug all these little pieces into the formula. So if this is U and V, right, UV, then this is equal to U times V. So there's U times the V.
Mhm.
So this should be
Oh, negative.
negative. So good thing we went over it again. Minus as built in. V du, where du is just the dx this time. So V du. So all I do is just plug in the pieces from here. So it's up to you to choose the U and dv, these two pieces. Usually you want this to disappear if you see a variable. But most of the time you want to pick a dv that you can integrate. So if dv is something you don't know how to integrate, then you probably picked a bad dv to use this formula.
What is DV stands for?
Derivative of v. So just the
Oh, derivative of V. Still have to re-review. Okay.
Yeah, so you have a product here, product. So in order to integrate a product like this, you use this formula. But you need to find the UV and DU. You need to find all those pieces to use it.
Yeah.
And then once you do, you either do one more integral right there. See where that came from here? The integral of this turns into that.
I see.
Okay. So now evaluate and take the limit. So if you plug in 0, right, the limit as a goes to -infinity, 0 e to the 0 minus e to the 0 minus b e to the negative b. Oh, sorry, a, not b. What was it? Oh, yeah. E to the negative a minus e to the negative a. Okay. So first part's no big deal, right? This will be 0 minus 1. Distribute that, it'll be negative a e to the negative a plus e to the negative a. So then you rewrite it just so you can see it better. So -1 minus a over e to the a plus 1 over e to the a. These go to 0, right? And take the limit.
Mhm.
Well, actually, hold on a second. If it was positive infinity, they would go to 0. They do not. These go to infinity. So diverges. My bad. Oh, I smeared it. Do you see why it's infinity or no? I didn't show it.
Yeah, can you go over that real quick?
Sure. Yeah. So this is negative infinity, right?
Mhm.
So, I mean, this is improper, but just so you can see it. This is, if we were to quotation marks plug in infinity. You see that this would be, right? Be a 0. Whenever you divide it by 0, you create this infinity type of scenario. Excuse me. Again, this is improper, but that's the idea. If you graph it, it's a little, you might be able to see it as well as to why. Right, this keyboard's broken. Okay, so that would be so visually, another way to think about it, instead of weird algebra. If we're going to negative infinity, we're shooting off to the left side, right? For 1 over e. So I'm going negative infinity, that means it goes to infinity
Mhm.
on the y. Because the limit is the y values, right? Does that make more sense?
Okay.
And so we have this scenario, right? Some number over ex or whatever. So
Mhm.
when this goes to infinity, it's going to the left side. So no, negative infinity, sorry. Goes to so the y value becomes infinite. Let's see here.
I think it's starting to make sense.
Yeah, you got to review. If you've forgotten, I'd recommend reviewing the infinite limits from Cal 1.
Yeah, I'm definitely gonna have to.
That's probably where the disconnect is coming right now.
Yeah.
Trying to see if I have some notes I could give you here. Mhm. Yeah, here's a review to look over when you get a chance. It'll help with the infinite limits. All right, but that's pretty much it for this section. It's just over and over again. Integrate, pick the limit. Integrate, pick the limit. You just need to be comfortable with the limit and the integral. So if it's a hard integral, well, it may require you to look into inverse trig or partial fractions or trig sub or u sub. Could be it could really be anything. You just tack on a limit to it at the very end. That's the only difference. But that's the end of chapter 8, though. So
I didn't see any homework for that chapter
which one?
on chapter 8.
8.8?
Yeah, there's no.
Let me see. It's there. It's just not in order, I don't think. What do you mean inside Canvas? Is that what you're saying?
Yes,
Oh, okay. Let me check. Maybe it's not unlocked.
so I see 8.1 basic integration is unpublished.
Oh, I see. Yeah, it was not published for some reason, the chapter 8. But you were able to get in through the homework, right? The homework link.
Yes.
Hit refresh. It should be there now.
Okay. Yeah. They're here already.
I'll go ahead and open chapter 9 to
So you said the exam will be 26, October 26?
no, that's too soon. I don't think that would be very nice.
Over here it says October 26.
No, I know that's something I need to update. It's an old text. So let me go ahead and unlock the test. So test will be due, I think I agreed to say November 3rd, right? So I said,
I guess, yeah. Let's see.
you can take it any time before then. I'm not saying
Yeah,
wait
third,
wait till
November
then.
3rd. Like somebody said they're gonna have a surgery or something like that.
Yeah, that's what I remember. Okay. But if you want to do 26, that is your decision. Of October. Okay. So we have some time. So I'm gonna post this just to save some time here. The review I did last semester, but we can also look at it ourselves a little bit. And then next time we're gonna hit chapter 9 pretty hard. So expect about 2 or 3 sections on Monday of chapter 9. We'll probably stay till 10:10 or something. Okay, so review, where is it? Here's the review for chapter 8. So the exam should look very similar. It's just going to be the entire thing is integrate, 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 integrate. At the very end, they have integrate with improper pieces. So it's going to be this what we just did right now. So you do the integral and then you take the limit. Okay.
Okay,
So let's see here. Yeah, which one would you like to do out of the first 3?
this is a tree.
You want to do 3?
Mhm.
Okay. Yeah, it looks kind of weird. Let's see how it goes. Okay. So exam 3 review. Number 3. So the integral of 3x minus 1 over the square root of 3x minus 1. Notice how I don't tell you what technique to use, right? So what technique should we use? Excuse me.
Use substitution.
What's that?
Use substitution.
You. Yeah, it could work. Let's see. I think. What would be your U?
Three X. Oh, no,
Which one?
3x minus 1.
Because it looks like the
Actually,
square root's only on the 3x, right?
Correct. Oh, I thought it was on the whole thing.
Oh yeah, me too.
So yeah, it's a little weird, right? So it could be anything from chapter 8. So for sure it's not by parts. We know that one, right? It's not that one.
It could be.
If I were to do, let's think about this. If I do use some on this guy, I still have to deal with that nonsense.
I think U is gonna be square root of 3x. Yeah.
I let you be that. That's a tricky one. I'm not seeing it at the moment. Let me look at my trig formulas. One moment. There might be a weird trig sub or a clever U sub. Well, let's try it, I guess. I don't have any ideas at the moment. So if I were to do this, then I would only change this to a U, which doesn't really help. I could separate into two integrals, but that doesn't really help either. Yeah, it's not going to work. And for trig sub, it needs to be an entire square root on the bottom. So that doesn't work. I think we may have to do oh, I see. Man, that's sneaky. I didn't see it at first. Let me show you. This is just a weird problem. You agree that this is the same, right? And then once you have a square minus a square, you remember that's going to be a difference of squares. You see what I mean?
Okay, U is.
Does that make sense?
Let me see.
Right, because this right here is the same as square root 3x squared, right?
Mhm.
1 and 1 square are the same. So then you can do difference of squares to get this. So then you can cancel this guy.
Okay.
So now you have an easy integral. Isn't that weird?
Oh.
Give me one moment, guys. Sorry.
Sorry, I can't hear you.
Can you hear me?
Yeah.
Oh, should tell me, man. I must have hit the mute button on the side of my headset. My bad. Okay. So let me redo that since you missed it. So if I do the sub just for this first part, that'll be du over 3, right? So I did the sub here, let u be 3x. Du is that, just like usual. That replaces this u and that dx. That one dx will be here, so that'll be a simple x plus c. Integrate this guy. That'll give us this plus x plus c, which will give us a final answer of 2/9 3x plus x plus c. But it looks like if I would have done it all at once, it would have been the same. See how I separated them? I could have left it like that and did the whole thing at one time.
Mhm.
That's what I did when I was muted. But I decided to do it the other way this time. Turns out to be the same. Anyway, does that make sense?
You, yeah, can you put it down a little, like scroll it down? There you go.
Any questions on this number 3 here?
No,
Okay. It's back to the exam. But you picked a good one. All right. Let's see. Yeah, on this one, if we don't have to do it, but I would separate x over x plus 2 and then 10 over x plus 2 to create two integrals. See what I'm saying?
Mhm.
And then start. Don't try to do it all at once. Okay. This one, this guy, what number is that? 4? 1, 2, 3, 4. So 4, 5, and 6 are all by parts. Looks like the first 3 are substitution type, I think. Let's do, I don't know. Which one would you guys like to do? They're all about the same for me, I think.
Let's do what this is y square sin to the 5th. See what sin 5 y, that one.
Okay. One, 2, 3, 4, 5. Okay, so this is going to be by parts. So you can do tabular method or by do by parts 2 times. So I'm going to do it the long way so you can see the practice of by parts since you guys forgot. So integral is formula.
These problems, are these problems from the review test or homework?
From the review test. It's 5 actually. Shit. 1, 2, 3, 4, 5. Yeah, and I'll send you. I'll post a video as well from last semester. But feel free to ask questions whenever you have extra time. Okay, so u dv is equal to u times v minus the integral of v du. So you want to choose, since I see a power polynomial type, that's the one that kind of tells me as a hint. I should make that my u. dv needs to be something you can integrate. So if it turned out that I could not integrate this, then I should pick something else. So the integral of this guy is cosine 5y over 5. And the derivative of that is going to be 2y dy. Right, I'm going to skip the the basic integral here. So now this will become this will become u times v, so y squared times negative cosine of 5y over 5 minus integral of v du, which will be negative cosine of 5y over 5 times du, which is 2y. So this will be negative y squared cosine of 5y over 5 minus minus will be plus the integral of 2y cosine of 5y over 5. I forgot to put my dy there. So now notice I have to do another by parts. That's why I showed you guys the tabular method, because it lets you kind of speed this up. But I don't want you to use a tabular unless you understand the basic one. So there's u and du. dv is chosen to be the cosine. The integral of that guy will be sine of 5y over 25. Okay. So now this integral, I'm gonna go ahead and tack on this little piece here. So the integral is going to be, the formula is, right, u times v, u times v. Minus the integral of v du. So this integral is an easy one compared to the other one. So this will become positive cosine times the 2 of 5y over, what's 5 times 125, right? Plus c. Okay. So we had to do by parts 2 times and some, some trig integrals. Any steps that you guys have questions about?
Just, let's see. Same for y over 25 times 2. Where you get the number 2 over here on before the dy?
One more time.
The number 2 you have over here in the bottom.
this 2?
Yeah, yes.
Oh, that came from the formula, because it's v du, right? So it's 2 dy.
Oh, okay.
So all I'm doing is following the
That's it.
formula, and then the formula forces me to do an integral again, which sometime is another by parts.
Yes. Okay.
So on the video, watch the tabular method. So try this one with the tabular method, and you're gonna see it's gonna be easier. Well, I mean, you know what? We could do it if you guys want. You want to do this one again with tabular?
Yeah.
Oh, shit. I'm out of paper.
Oh,
Let me use a different. I have the dotted paper in here too. That's when you know it's been a long day when you run out of paper.
uh-huh. So what time you start today?
First class was at 11 a.m.
Wow.
Okay, so y squared sine of 5y dy. Okay, so let me pull up the tabulars just so I don't make sure I don't miss anything. 8.2, here we go. So remember I told you you take the u and then the dv over here. Does this look familiar at all? And you
What?
choose, what's up? See?
Uh-huh.
Okay, so remember we did, you keep taking derivatives until it disappears, right? And then you do plus, minus, plus, minus. You don't really use the 0 though. And over here, you take integrals until you match up with this one, at least one below. So integral of sine is going to be negative cosine of 5y over 5. Integral of that will be negative sine 5y over 25. Then one more time will be cosine. Integral of sine is, yes, integral of that. So yeah, okay, sorry, double checking. Okay. So then you just draw lines like this. You do this one, that one. Actually, sorry. Yeah, I forgot. You skipped the first one. You go like this. This one. This is like the UV. See what I mean?
Mm-hmm.
So plus, minus, plus, it always alternates this way. So the answer to this integral is going to be y squared times the negative cosine of 5y over 5 minus, that's the minus built in from here,
Mm-hmm.
2y times negative sine of 5y over 25, then plus 2 cosine of 5y over 125. So the answer will be negative y squared cosine of 5y plus negative 2y sine 5y plus 2 cosine of 5y over 125. And I think that's what we got, right?
Mm-hmm.
Let's see. Shit, so I forgot what page that is. Well, again, you guys check. Do you have the answer or no? No.
Just a second. Can I finish it?
Yeah, I'll put it back. I just want to see the answer. Yeah, that's what we got. Same thing. So this is taking care of the by parts for you. So this is called the tabular method for by parts. So some people like this one better. The only time it gets a little difficult to use is when this doesn't disappear. So you see how this goes to 0? If this keeps cycling forever, then you need to figure out, you need to stop when it repeats itself, meaning you keep going until you end up with what you started with. And then you write the question down. But they're gonna have to have that integral piece that tacked on. So once you repeat it, you add it to the other side. You add it to here, and you get two of them. So you solved it at that point. So that's the only time that tabular gets weird, but
You know what? I don't think I have missed any class, but I don't have that thing.
you don't have the
I don't have,
notes?
I don't have 8.1 or 8.2. I started on the 8.3.
Yeah, we skipped 8.1 because that was just basic substitution or basic
Okay.
integrals.
Yeah, but I don't have 8.2.
8.2.
I can't find it. I'm
That's weird.
yeah, I got on let's see, on one of your videos is 8.2 dash point 8.3,
Mhm.
but it starts with 8.3. I don't have anything for 8.2.
Let me see. I thought I saw it just a second ago, but let me go back.
And that's
Maybe.
one on October 6th.
Man, that'd be hilarious if we just skip a section,
Yeah, I don't remember seeing that thing.
but
I've got it in my notes, but I don't have a date written down. But I've got integration by parts in section 8.2. I've got the tabular method written down where we went over it. So I don't know.
yeah, here's the
don't know.
video.
Do you know how you have the date?
No, I didn't write down the date, unfortunately.
No.
It looks like it was. Well, I uploaded on the September 12th.
September or October?
This September, according to YouTube.
Oh, September 13.
But yeah, the weird thing is I don't have it. I didn't upload on my notes. I only have 8.3, but I do have the video of me doing it. How crazy. Somehow
Because let's see.
only one guy has the notes for some reason.
Pretty sure it was
Yeah.
on the 6th, October 6th.
October 6th.
Is when we went over it. Yeah.
Oh, probably. Okay, probably in the notes. Let me check the video.
All right, cool. So starting to wonder. Someone erased my memories or something.
Oh, yeah, you have it in the video. You don't have it in the notes.
So if you
Yeah. Okay.
and V,
You had it in the video, not in the notes. That's why I can find it.
Yeah, it didn't. I guess it didn't scan when I sent it. But it's in the video, but I don't have the actual like. Thing.
Yeah, because I remember we didn't have a class, but I saw something that you sent. It was a Sunday.
Yeah, I remember we had a class that day, but I don't know.
I think it was the day when it was raining or something like that. I don't remember.
So weird, but
yeah, no, but I found it. I found it.
But yeah, I guess rewatch it. I mean, maybe it's a couple. Maybe people didn't. Not many people came that day. Just a few people. Who knows? Who knows? But so there it is again, right? We just did it twice. So hopefully that helps.
Yeah. Okay.
So do this technique on 4, 5, and 6. It looks like tabular method will work really good on all 3.
Mhm.
Let's see here. So over here is remember the I think it was 8.4 or 8.3 when we had the trig function that had the powers. Remember how we had to like break a piece off and do a substitution? You guys remember that?
It was the,
No, let's do that sine one, I guess.
when the power is odd and positive and all that stuff, right?
Mm. Yeah, if it's odd or even, remember I had those notes.
Yeah, when the power is of cosine is odd and positive. The power of sine is odd and positive. Yeah, okay.
Okay, let's do this guy. So this is an odd sign. So I'm thinking I should break a piece off here. Then do the trig sub or trig identity here, which is gonna be 1 minus cosine squared times sine x. So we let u equal cosine. Du equals negative sine x dx, right?
Mhm.
So then this will become 1 minus u squared negative du. You gotta divide it out. So I put the negative in front. So that'll be u. So that'll be negative u minus u cubed over 3, which is actually negative sine x plus sine cubed x over 3. So it was those type. And then of course, oh, actually there was bounds, but we'll just skip that part for now. Any questions on that one? Not too bad. Okay. So that's same. You're gonna use similar techniques for this one. I already forgot the number I'm on. So it's 1, 2, 3, 4, 5, 6, 7. So this is number 7. So for 7, 8, and 9, you'll use one of those rules I gave you. So if it's even or odd, whatever. See how this one's even and odd. This is the tangent. Remember, I give you a set of rules for tangents and secants. So after that, it looks like more of the same. But, well, I guess you guys have any questions on these three? Is this one similar to the other ones, or these two are, I think, a certain type, and then this is, I think, trig sub, or no, inverse trig actually.
Okay. Can you do that?
Is this one? Or,
Yes, that one, the one, that one.
okay, sure. I don't remember what number we're on. I need to rename those things. Piss me off. Okay, so integral of 0 to 1 dx square root of 81 minus x squared. So we need to remember remember that sheet I gave you with all the integral rules. There's one for all the inverse sines or inverse trig functions. So this one's going to be a sine type. So you first have to rewrite it. You first have to identify that it's a sine type. And then you rewrite it. So this is my A. So it's a 9 though, but in the formula, this is like an A and a X or A and a U or something, I forget. When you apply the formula, this is going to be sine inverse of U or X over the A, which is 9. Actually, you know what? Let me double check the formula before I go any further because I feel like that's not right. Inverse trig integrals. Here it is. You remember these? Right, so if it's a squared minus u squared, it's equal to arc sine u over a. Right? So that's what we got. Only last step we got to do is integrate from 0 to 1. So it should be on the page I gave you. I'm sure I wrote it down as well, but if you need it, let me know later. So plug in the value. So it's 1 over 9 minus sine inverse of 0. Sine inverse of 0 is 0. So you end up with this. So all we really did is use a formula, which is this guy here, du over a squared minus u squared is equal to sine inverse of x over a. So there was nothing weird in that question. You just had to know the formula. The next two look like trig sub. You see that? Remember how we had the I think it was 8.5 or 6. Depending on what it looks like, you can have either it's going to be a sine or a tangent or a secant. Because remember, you build a triangle. So it's going to be one of those.
Okay.
You want to do one of these?
Yeah, let's do one.
Okay. Well, this one's easy. That's actually something. This one's a basic formula type. This one looks kind of hard. Let's do that one. Okay, so the integral the square root of x squared minus 9 dx over x. So what type is this? So let me bring up have like 1,000 tabs open. Trig sub. Son of a bitch. Keep using a broken keyboard and I keep forgetting.
Mm.
Okay, so it was these here. Well, they actually have one similar to this one. Excuse me. So we said that if you see a number squared minus x squared, that's going to be a cosine or a sine. Use this as your sub. If it's plus, use this as your sub. If the variable is first, use the secant. Do you remember how we wrote down all those formulas?
Yes.
So we're gonna do we're gonna do here. Okay, so we have scenario secant. I think that was scenario 3 in your notes. Let me pull up the notes.
Oh, okay. Yeah, you have the negative and yes.
That was 8. Was it 8.5? No. 4, right? Yeah, there it is. Okay. So it looks like, oh no, I wrote, it was number 1. I'm sorry. It was rule number 1. Okay, so we said so first we rewrite the question. So we say let u equal a sine theta. Right. So our u is actually x. So we're gonna let make a note here. A is 3, u is x. If we follow the notes. Right.
Mhm.
So that'll be x equal to 3 sine theta. So dx would be 3 cosine theta d theta. And if you solve for sine theta would be equal to x over 3, right?
Mhm.
Which will allow you to build a triangle. Opposite hypotenuse. This Pythagorean theorem will give us square root of 9 minus x squared. So we're gonna need all this information to first use this to sub and integrate, and then we use this to come back to x.
Mhm.
Okay, so this will be okay. X is now 3 sine theta squared minus 3 squared. Dx is now 3 cosine theta d theta over x, which is 3 sine theta, right?
Mhm.
Let me write it prettier over here. So this will be the square root of 9 sine squared theta minus 9 times 3 cosine theta d theta over 3 sine theta. So factor, that'll give us 9 minus, or times 1 times sine squared minus 1, right? That's kind of weird. One second. Make sure I wrote the question correctly. Yeah, we're good. So this factor a negative out. Hmm. Yeah, because there's no identity for sine squared minus 1. There's 1 minus sine squared. So what the hell happened? Did I use the wrong substitution? Yes, I did. So we were, it was, damn it, it was tangent. It was the secant. I'm sorry. This is not gonna work. Start over. My bad. I lied. I was all fake math.
It's late, that's why.
Yeah, you know, maybe we should stop here, guys. We'll on Monday we'll do chapter 9, and then at the end I'll try to do a couple from the review. Okay.
Okay.
Either way, you guys, it sounds like you guys are not even done with 8 anyway.
Mm-mm. Yeah.
I'll give you time to get there.
What did you say? Did you put the due date for the exam?
November 3rd.
November 3rd. Thank you. Appreciate it.
All right,
See you
amigos. I'll see you guys Monday.
Monday.
Uh,
You gonna send